Let's take a look at example 4. This one is the same basic setup except for changing some of the numbers. R1, R2. Okay, so when we're solving this problem, we have to realize is that the voltage that collects on this is going to be the same as the voltage across this resistor. And so in order to get the voltage across this resistor, I need to find the current. And so the current a long time after this has been closed is going to be 20 volts over 35 kiloohms. So this is going to be 5.7 times 10 to the negative 4 amps. All right, so if that's the current, I can multiply that by R2, and that gives me the voltage across this. Right, so that V on R2 a long time later is going to be V times C, which is 8.57 volts. So that's how much voltage now is being discharged across this. Okay, and so the current, now when it's discharging, the current on R2 is going to be given by the voltage on the capacitor as it's decreasing divided by R2. So V on the capacitor, or which is equal to the voltage on R2, divided by R2 times e to the negative t over tau. All right, now when I go to find the time constant, I find that the time constant is 4 times 10 to the negative third seconds. That is also the time t that we're asking for in this. And so this ends up just being negative 1. So VC is 8.57 over, and then this is 15 kiloohms times e to the negative 1. And what is that going to give us? It gives me 2.1 times 10 to the negative 4 amps. Okay. Or, I mean, the other thing I can do, since I know it's one time constant, I can find what the voltage is. I can find 37% of the voltage and then divide that by 15 kiloohms, and that will give me the same thing.